Okay, today our lesson will be logarithmic functions. This is the first part. We'll continue with logarithmic functions with the next lessons. Logarithmic functions, they were invented by John Napier in the 17th century. So what are logarithms? Logarithms are the inverse of exponential functions. Inverse, let's say this is a graph of y equal to let's say the graph of y equal to 3 to the power of x. Inverse of this on a graph, inverse is always the reflection on y equal to x. This is y equal to x. Therefore, the inverse of this is the mirror image of this graph on y equal to x. The y-intercept here is 1. Therefore, the x-intercept here should be 1. So, the image of this will be, this is a mirror image. Therefore, this is inverse of this. Inverse means instead of y, I write x, and instead of x, I write y. So this inverse, this is in exponential form, but I write this one, if I want to isolate the y, we write y equals log of x to the base of 3. Therefore, these two are the same. This is in exponential form, this is in logarithmic form. So, what is the domain of the exponential form? The domain of the exponential is all real numbers. X belongs to R. The range will be, the range starts from y greater than 0. Y would be greater than 0, but not equal to 0. The asymptote is the x-axis, which is the y equal to 0 line, or the x-axis. For logarithmic functions, the x would be everything greater than 0. The range would be all real numbers. And the asymptote will be x equal to 0, the y, the vertical line, or the y-axis. So as we know from the inverse functions, the domain of the function is the same as the range of the logarithmic function because they are inverse. Okay, so these are the basic things for logarithmic functions. So let's see if I had from what we have seen here, we say, let's say y equal to a to the power of x. This is exponential form. Exponential form. If I want to change it to logarithmic form, the x is the logarithm, therefore log of y to the base a equal to x. The exponent is always the logarithm. So this is logarithmic form. They are equivalent, the two are equivalent. Okay, so let's see some examples here. So I have log of 16 to the base of 4. Log of 16 to the base of 4, or I can say is equal to what this equal to here. So this one can come especially from if we are given 4 to the power 2 equal to 16. This is exponential form. If I want to change this one to logarithmic form, log of 16 to the base 4 is equal to 2. This is logarithmic form, this is exponential form. So from what we see here, log of 16 can be written as 4 to the power of 2. This is 4. So we have seen that now this 4 and 4 are the same. The base is the same as this one here. And we got the answer is 2. So this exponent must be my answer. So for anything, for any logarithm, if log of a to the power of b, if the base is a, if this and this are the same, then my answer will be the exponent. Okay, similarly, log of a to the base a, the exponent is 1, so this will be always 1. Okay, so we can say, so log of 1 to any base is always equal to 0. This is another thing we need for logarithms. Or we can say a log of x, if the base is a, if these two are the same, then my answer will be x. These are the three things we need for this section here. Okay, so let's see more examples here. Log 64 to the base of 4. In order to evaluate this without a calculator, I have to change this to the base of 4. So this is the same as log of 4 to the power of 3. 4 and 4 are the same, so my answer should be 3. If I have log of 25 to the base of square root of 5, so I cannot change the base. Therefore, I have to change this one here, the function 25. So how do I change 25 to square root of 5? So square root of 5 to the power, what gives me 25? Square root of 5 times square root of 5 times square root of 5 times square root of 5. 4 times to the base of square root of 5. If these are the same, then my answer is the exponent. And then 3 log of 5 to the base 3. So my answer no matter would be this answer here, 5, because 3 and 3 are the same, therefore my answer is 5.